Yes. Motion in a straight line. What is this? What do we study in this chapter? To understand from basics, see, we have different branches of physics, like mechanics is one branch, optics is one branch, electromagnetism is one branch, heat is one branch, then waves and oscillations is one branch, modern physics is one branch, nuclear physics, geophysics, biophysics, different several branches are there. Out of all these things, these are the 6 branches that you will be studying in your up to your +2 level. Out of this, if you take the first branch, mechanics, a very important and a very extensively used branch of physics, mechanics. Mechanics is, it is the study of motion of objects, basically. Mechanics is the study of motion of objects. Study of motion of bodies under the influence of forces. That's what is mechanics. And this mechanics, it can be divided into 3 sub branches. One is kinematics. Second is dynamics. And third is statics. What do we study in each branch? Kinematics. Kinematic means which is moving, which is in motion. We call that thing as kinematic. And kinematics is that part of mechanics where we study the motion of bodies without considering the cause of motion. That means we do not bother what made that body to move. We will only study how that body is moving, like how much distance a body covers, with what speed it is moving, how much time it takes, things like this. Kinematics, without considering the cause of motion. And dynamics is the study of motion of bodies considering the cause of motion. Considering the cause of motion, which is nothing but a force. Cause of every motion is a force. So in dynamics, we include the forces acting on the body also. In kinematics, we don't include the forces. Then statics, stationary. It is the study of not motion, study of bodies that are in equilibrium. That are in equilibrium. Equilibrium is if 2 or more forces are acting on the body and the body is not moving, then you say that it is in equilibrium. So what are the conditions for a body to be in equilibrium? How does it behave? We study all those things in statics. Right now, this chapter, motion in a straight line, it is a part of kinematics. And further, you can classify this kinematics into two parts, 1D and 2D, 1D motion and 2D motion. We'll be studying both in our syllabus. Okay, right. So let us first of all take kinematics, which is the study of motion of bodies without considering the cause of motion.
Sir, can we say kinematics is a part of dynamics?
Uh,
Okay.
yeah, you can say. But once you include force, it is no more kinematics. Right. So motion in a straight line. We should understand clearly what do these two terms mean, motion and rest. A body can be in either of these two states, motion or rest. So when do we say a body is in motion and when do we say a body is at rest? If a body is not moving, it is at rest. If a body is moving, it is motion. It's not a, it's okay, a logical explanation, but technically, motion and rest, these two states are defined with respect to the position of the body. Motion, you say that any body or some body is in motion if
Sir, once can you scroll up?
the position of the body changes with time. Then you say the body is in motion. On the other hand, if the position of the body does not change with time, then you say that the body is at rest. Okay, and again, motion and rest, these two are relative things. The states of rest and motion are relative. The states of rest and motion are relative. Relative means depends on some, they have something in common. To understand what this means, let us say you have two people A and B are going in a car which is moving in this direction on a road, and another person C is standing on the road, he is stationary, and he is watching A and B. Now, if you ask C, what is the state of motion of A, C will tell that A is in motion. For C, A is in motion. Okay. But the same A for B, person B, who is in the same car, A is at rest. A is in motion for C, but A is at rest for B. How can this be? How can a body have two states of motion simultaneously? It's not simultaneously, it is changing because of the frame of reference. Frame of reference. Motion of A is being observed by C from ground, and motion of A is being observed by B from the same car. Same car. So we call this thing as frame of reference. Frame of reference is the position or the point from which you are observing motion of some body. You call it as frame of reference. Frame of reference. What is this frame of reference? It is nothing but it is a set of three coordinate axes.
X, Y, and Z, sir.
Three coordinate axes X, Y, and Z meeting at the origin along with an imaginary clock to measure time, because motion is directly related to time. So a set of three coordinate axes X, Y, and Z axis which meet or which intersect each other at the origin along with an imaginary clock, you call that as a frame of reference. So your frame of reference will be something like this.
Yes, sir. Yes, sir.
This is x-axis, this is y-axis, and this is z-axis. And imagine that there is a clock here, which is used to measure time. Okay, you call this as a frame of reference. And uh, again, coming back to this example, if C is observing the motion of A, then this frame of reference, XYZ axis, you imagine that this frame of reference is attached to the over the head of C. This is x-axis, this is y-axis, this is z-axis. Okay, from this frame of reference, C is observing A, and this frame of reference is fixed, it is not moving, stationary, and A is moving. So C will say that C sees, person C sees that the position of A changes with respect to time. At, let us say, time t equal to 0 second, A is at origin. If you take this x-axis like this, let us say this is the x-axis. At t equal to 0 second, A is here. 1 second, A goes here. 2 second, A goes here. 3 second here. 4 second here. 5 second here. So as the x parameter or x coordinate of A, the x coordinate of A is continuously changing with time. So C will say that A is in motion. Okay. Or if C, let us say, instead of looking at this car, C is observing a stone which is falling from a certain height. Then what does C see? Person C sees that the y coordinate of this stone is continuously changing with time. Then he will say that the stone is falling or the stone is moving, right? Or if a, let us say,
Sir?
a bird is flying, let us say a bird is flying, then the bird can fly in x direction, the bird can move in y direction, the bird can move in z direction. So C will say that x, y, and z, three coordinates of the bird are changing. So he will say the bird is in motion. Ritvik and Linisha.
Sir,
Hmm.
sir, in the car example,
Hmm.
from the point of view of C, the car is moving in the x-axis, no, sir, in the point of C.
Hmm.
Yes.
Yes. Linisha.
Sir, B is B is also in car only, sir.
Yes,
Sir, then who is right, sir? B or C?
both are right. Both
From
are
their
right
point of view.
from their frames of references.
Okay, sir. Thank you, sir.
If you are traveling in a train, your brother, sister, your father, mother, whoever is sitting beside you, they are at rest for you. But for a person standing on the platform, both of you are in motion because
Okay,
you are
sir.
looking at your friends from your frame of reference, and the person on the platform is looking from his frame of reference. So, whether a body is at rest or in motion, it depends on the frame of reference.
This is the point of view, sir.
Point of view is a general term. Technically, we call it as a frame of reference.
Okay, sir.
So that's why we say that the states of rest and motion are related. One body which is in motion for someone might be at rest for someone else. That depends on the frame of reference. Okay. Then, if you look at a larger view, there is no body in the universe. There is no body in the universe which is at absolute rest. Absolute rest means rest for every frame of reference. For any frame of reference, if you watch that body from any frame of reference, that body should be at rest. Then you say that it is at absolute rest. And there is no body in the entire universe which is at absolute rest. So if suppose if you take you are sitting there, you have your table or your book, something there on the table. Is it at rest? Yes, it is at rest for you. It is at rest for you. But for someone who is watching you from the moon, let us say with a telescope, then that book or even you or your table or the wall of your house or your entire house or building itself, they are not at rest. It is moving because Earth is rotating. Everything on the surface of Earth is in motion. Okay. And that fellow who is sitting on the moon, he is also not at rest because moon is revolving around the Earth. Right? And someone who is on Mars is also not at rest. Mars is also revolving around sun, rotating around itself. Then for someone who is sitting on the sun, imagine, is he at rest? No. Sun is also rotating about its axis, and
Galaxy.
also it is revolving around the center of our galaxy, which is Milky Way galaxy. So sun is also not at rest. Then is our galaxy stationary? No. Milky Way galaxy and all the other innumerable galaxies that are present, they are continuously moving away from each other. That's what we came to know from Big Bang theory. Everything, every galaxy, every star, everything, they are continuously moving away from each other. The universe is expanding. So you don't find any single body which is at absolute rest. Okay. So technically speaking, that you are at rest is also wrong. The table is at rest is also wrong. You and the table and your house are rotating, are moving with the speed of Earth, which is around some roughly, I think, 500 kilometer per hour, approximately. You'll calculate that value when you come to that particular chapter, circular motion. So there is nothing which is at absolute rest. Everything is in motion. Everything in the universe is in motion. That's why study of motion is so important.
Sir, I have a doubt.
Uh,
Sir, sun is always rest, no, sir. It doesn't
no,
move at all.
sun is not at rest. It seems to be at rest for us, but sun is moving. It is circling the center of our galaxy. Just as how Earth moves around the sun is moving around the center of our galaxy, and it takes some millions of years to complete one round around the center.
Okay, sir.
And along with the sun, all the planets, they are also moving along with it.
Sir, are trees also in motion?
Yes, Earth is also in motion.
The Milky Way galaxy is also moving, sir.
Yes, All the galaxies are moving away from each other. Distance between one galaxy and the other galaxy is continuously increasing. Universe is, it's like you take a balloon, mark 2 points on the balloon, 2 dots, and blow air into that balloon. What happens to these 2 points? The distance between them goes on increasing.
Yes, sir.
The same thing is happening with the universe. It is continuously expanding. And we don't know until when will it expand, will it stop or not. Or some theories say that this expansion will continue for some millions of years to come, then it will stop, and then it will start contracting. Different theories are there. But as of now, everything is moving away from each other.
Sir, that means that the universe is automatically expanding, sir.
Yes.
Okay.
How do we know it?
We come to know about it from what we call as Doppler effect. There is something called Doppler effect, which with the help of wavelength of light that is received from different stars, we measure the wavelength of light, and it is seen that this wavelength is changing continuously. Wavelength is changing means that source of light is, it must be either moving away from us or moving towards us. We call this as a blue shift and red shift. Based on that thing only, we calculate approximately the distances of galaxies or distances of stars from Earth. Okay, so finally the point is everything is in motion. Okay, and to study the motion of bodies near the surface of Earth, we call this as terrestrial motion. Motion of bodies on or near the surface of Earth, like a car is moving on a road, or a ball is thrown vertically upward, or something is falling down. All this thing is terrestrial motion. To study this kind of motion, what we do is we imagine that Earth is at rest. We imagine that Earth is at rest, and with respect to that stationary Earth, we describe the motion of all bodies. Because if you consider the motion of Earth also, then things become complicated. It's not easy to understand mathematically. Any complications will be there, relative velocity, all these things will come into picture. To avoid the complications, what we do is we imagine or we take that Earth is stationary, Earth is at rest, and we describe the motion of bodies. Suppose if I tell you that a car is moving with a speed of 10 meter per second, then it means I am, who is observing this car, I am at rest. I am at rest. I am at rest means ground is at rest. Ground is at rest. So on stationary Earth, I am standing on stationary Earth, and this car is moving with 10 meter per second velocity. That's why we say that its velocity is 10 meter per second with respect to ground. All the motion that we study here is with respect to ground. So all terrestrial motion is described or studied with respect to ground or earth, which is assumed to be stationary. Okay, motion, rest, they are relative and frame of reference. Right, now coming to the first terms that we need to understand motion, they are distance and displacement.
Sir, can you scroll up once?
Distance and displacement. What are these two things? Distance is a common general word. We use it in our daily lives also. Distance is used to convey how far away something is, okay, or what is the, how much is the path that you should travel to reach that point. That is what is conveyed by distance. You say that the distance of your school from home is 2 kilometer, or distance between two cities is 100 kilometer, 200 kilometer, like that. They are defining it technically, distance. It is the actual path length, between 2 points. Actual path length between 2 points is distance. Okay. And what do you mean by this actual path length? Let us take an example. Suppose this is point A and this is point B. This is point A and this is point B. And you go from point A to point B along a straight line, straight like this. Then how do you measure or how do you calculate the distance traveled by you? To calculate distance or to measure distance, what you do is you take a measuring instrument, let us say a scale or a measuring tape, place it along the path that you traveled and measure the length. You'll get distance. Okay, let us say this is some 10 meter, for example. So distance between A and B along this path, straight line path, is 10 meters. Suppose I go from point A to point B like this, in this path. Now what is the distance traveled by me? I should again take a scale or a measuring tape, place it along this path, measure it. You will get the distance.
50 meters or something like that.
It will obviously be more than 10 meter. Let us say it is some 15 meter. That is my distance. So distance has changed, it has increased. On the other hand, if I go from point A to point B like this, in this path, then I should again place the tape or scale along this path, measure the total length, I'll get the distance. And obviously, it will be further greater than 15 meter. Let us say it is some 20 meter. So like this, distance depends on the path you travel. Distance depends on the path traveled. It depends on the path traveled by the body. There might be more than one way to go to your school from your home. Along different paths, you will get different distances. One might be the shortest, one might be the longest, like that. That is distance. Now, what is this displacement? This is a very, very fundamental and very important difference between distance and displacement, which you should understand very clearly. We will be using these two things all over our chapter. Not only in this chapter, in the coming chapters also. Distance and displacement. Displacement is, it is the shortest path.
That means shortcut, no, sir.
Shortest path between initial and final positions of the body. If a body is moving, it will start from some point, it will stop at some point. The shortest path or the shortest distance between these 2 points, we call it as displacement. Again, coming to the same example, a body starts from A and goes to B. Let us say it goes along path 1. It goes along path 1. And what is the distance? 10 meter. What is the displacement? Shortest path. Shortest path. And I think all of you will be knowing from your geometry mathematics that the shortest distance between any 2 points will always be a straight line. So the shortest path between point A and point B is a straight line, which is this. And in this case, it is some 10 meter. Okay. If the body goes from point A to point B, point A is initial position, point B is final position. Body is going along this path 2. Body is going along path 2. Then what is its displacement? Its displacement is still this straight line because it is the shortest path. If the body goes from A to B along path 3, this path, even then its displacement is the same straight line from A to B, 10 meter. Distance can be different, it depends on the path followed. Displacement does not depend on path followed. It does not depend on path followed. Then on what does it depend? It depends only on the initial and final positions. It depends only on the initial and final positions. Rohan.
Sir, displacement can be called so only when an object has moved, sir.
Yes.
We can't say the shortest distance between 2 points is displacement, sir.
Shortest distance between 2 points is displacement. Okay, and that is also okay.
It has to be motion that's compulsory or maybe, sir.
If a body does not move, then there is no meaning in distance and displacement. No.
Yes, sir.
If a body is at rest, you have got nothing to study about it. You'll get something to study about the body only when it is moving.
Okay, sir. Then there's no difference between both.
Oh.
Okay, sir.
Okay, so displacement depends on initial and final positions only, not on the path followed. This is an important point. Keep in mind.
Sir, why is always the straight path the shortest distance?
Mathematically, geometrically, if these are 2 points, shortest distance between these 2 points will always be a straight line. It cannot be a curve like this. Then distance, what is the unit in which we measure distance? It is measured in SI.
Meters, sir.
Yes.
Unit of distance is meter. And its symbol is m, small m. Some students use capital M, which is wrong. Displacement also is measured in meter. Distance is a scalar quantity. Displacement is a vector quantity. And don't forget the vectors that we have learned. We will be using them here. Distance is scalar, displacement is vector. Distance will always be positive. Distance traveled by a body will always be positive. Why? Because distance is the actual path length traveled by a body. Actual path length traveled by a body. If a body moves, then the path that it covers, 1 kilometer, 1 meter, 1 centimeter, 1 millimeter, whatever the path is, this cannot be negative. This cannot be negative. If you measure the distance traveled by a body with a scale or a tape, you can never get a negative value, right? Whatever value you get, it will be positive. So distance is always positive. Whereas
Can
displacement
be negative.
displacement can be positive, negative, or
Or zero, sir.
zero. Displacement can be positive or even zero. How? We will see examples. Then another point is the ratio of distance to displacement. Distance to displacement. Modulus of displacement will always be greater than or equal to 1. Ratio of distance to displacement will always be greater than or equal to 1. Displacement can never be greater than distance. Let us try to understand this with an example. Suppose this is x-axis, this is the origin, this is 10 meter, this is 20 meter, this is 30 meter, this is 0, this is point O, A, B, C, this is minus 10 meter, minus 20 meter, minus 30 meter. This is point D, E, and F. Okay. Now, if I take different paths traveled by the body, let us see what will be their distances and displacements. Let us say, first of all, a body starts from point O and goes to point A. Body starts from point O and goes to point A. What is the distance covered by it?
10 meters, sir.
It's 10 meter. What
10
is its
meters.
displacement?
10 meters, sir.
10 meters
Shortest
over
path between O and A. Shortest path between O and A is a straight line, which is 10 meter. Okay.
towards right.
The body starts from O and it goes to B, then
20 distance, sir, and
A.
displacement 20.
Starts from O, goes to B, and goes to
30, distance 10, displacement 10.
10, 30,
covered
sir.
is
30.
Distance 30
Sir,
meters.
displacement is
30, sir.
displacement
displacement is
10.
10 meter. Displacement is 10 meter. To write displacement, you should look only at the initial position and final position. Initial position of the body was O. Final position of the body is A. And O to A, shortest path is 10 meter. Next, body starts from O, goes to C, comes to O. Distance covered is
3 meters.
60, sir.
60 meter. Displacement is
0,
Zero,
sir.
sir. Zero.
0. Correct. Because initial position is O, final position is also O. Shortest path between O and O is 0 because they are the same points. Displacement is 0, even though distance is 60 meter. If you start from your home, go to school in the morning, come back to home in the evening, you might have traveled 2, 3, 4, 5 kilometer distance, but your displacement is 0. If you start from your home, go for a world tour, go around the world, Australia, America, New Zealand, Singapore, London, wherever you want to go around the world. Again, when you reach your home, your displacement will still be
Zero, yes, sir.
zero, but your distance will be some thousands of kilometers. So that is the difference between distance and displacement. Body starts from O, goes to A, then goes to D. Distance covered is
Sir, 0, sir.
distance can never be zero. If a body moves, distance can never be zero.
Sir, is it 30,
O
sir?
to A to D. O to
Sir,
A,
20 meters.
it goes from O to A 10.
30 meters, sir. 30 meters.
A to D means A to O another 20, then O to D another 10, 30. Distance covered is 30 meter.
30 meters, sir.
Displacement is
10 meters.
Minus 10
Minus 10
meters.
meters, sir.
displacement is minus 10 meter. Minus 10 meter. Displacement is a vector quantity, and this negative sign tells you that the final position of the body is towards left of the origin. Body starts from O, goes to C, goes to F. Distance.
Sir, 90 meters, sir.
Displacement.
30 meters.
Minus 30.
Minus 30, sir.
So this is how. This is what is the difference between distance and displacement. Distance will always be positive. Displacement can be positive, negative, or even zero, depending on the initial and final positions of the body. And the ratio, if you take the ratio of distance to displacement, you will always get greater than or equal to 1. 10 by 10, 30 by 10, 60 by 0. Of course, this is infinity. This is a exceptional case. And 30 by 10, 90 by 30, all are greater than or equal to 0. Sorry, greater than or equal to 1. Another example, a person walks 3 meter towards east, 4 meter towards north. Then his distance is
7 meters.
Sir, the displacement is 5 meters. You actually already took this example, sir.
So 5 meters.
Displacement 5 meters.
displacement is the shortest path between initial position, which is this, and final position, which is this, which will be a straight line. This is a right angle triangle. Applying Pythagoras, you get this as 5 meter. But in reality, you are not applying Pythagoras, you are applying parallelogram law
Yes,
of
sir.
vector addition. Root of 3 square plus 4 square plus 2 into 3 into 4 into cos 90 degree. Root of 3 square plus 4 square. Root of 9 plus 16. Root 25, which is 5. Displacement is 5 meter. Like this, we get many examples. We will see some more examples to
Sir, I
understand
have a doubt.
clarity. Yes.
Sir, in the formula of parallelogram, we have to use only cos 90 degrees.
Cos theta.
Okay, sir. How we should know the value of theta, sir?
What is theta as per the
Okay, sir.
formula?
Okay, sir. The angle between.
Right. So this is the basic of what is kinematics, what is motion, what is rest, distance and displacement. Two basic terms. We'll continue tomorrow.
Sir, in this chapter,
Thank you,
about
sir. Bye,
what
sir.
we'll
Good night, sir.
discuss more, sir? Kinematics or dynamics, sir?
Kinematics. We are discussing kinematics.
Okay, sir. Thank you, sir. Bye.
Students, relax for 2 minutes.